Well, hello and welcome to another episode of the JUXTCast. I'm Henry Garner, and today I'm joined by Chris Ford, who's Technology Director at ThoughtWorks and author of the O'Reilly book, Agentic Engineering at Scale, which is currently available in early access. Welcome, Chris.
Really good to be here. Nice to chat about these things with you. I know you think a lot about these kind of topics, so it'll be a good conversation.
I hope so, yes. And why don't we dive straight in to
Yeah,
talk about the book? Because it's about agentic software engineering. I mean, there's so much I want to ask you, but
yeah,
first of all, what territory are you covering? And, what, if anything, did you deliberately leave out?
right. Good question. The thing I deliberately am trying to stay away from is the personal productivity aspects of using coding agents. I mean, to be clear, I'm very fascinated by that, and I think that's an important part of the whole. But there's two reasons why I didn't want to cover it in my book. First of all, that's where I think a lot of the attention and conversation is. How do I structure my agents MD better? How do I install this MCP server or whatever? But the second, more selfish one is that's the area that is most volatile. And so if you want to put the effort into writing stuff down in a book, you hopefully want it to last a few months. And so that's why I've decided to focus much more on the scale aspects as per the title. So how do we cooperate to deliver value with software over time as groups of people, as opposed to how do I hack together something awesome with Claude?
So you're looking more at the kind of the human aspects about how we organize ourselves around developing with AI?
So I would say it's the organizational and feedback aspects. So not just, oh, okay, what skills do people need to operate in this world, but more what are the feedback or feed forward, which we might get into later, mechanisms that organizations need to put in place so that when individuals and teams are using coding agents to get stuff done, they do it well, reliably, efficiently.
So I'm wondering who your ideal reader is. Are
Yeah.
they practitioners who are actually working on this stuff, or are they maybe one or two levels up the management hierarchy looking at how to organize their teams?
So I hope it's not just a book for managers, although managers are perfectly allowed to read it if they so like it. I think my target is people who have experienced that thrill or maybe productivity bump on things that they're doing at a personal level, whether it's hacking together something on the weekend or building a piece of software that they use to accelerate their own workflow, and who are maybe frustrated that they can't experience that same improvement or rush in the rest of their organization. So maybe a senior practitioner who has ambitions to help the rest of their colleagues take advantage of this interesting new technology. So maybe someone at the boundary of individual contributor and organizational thinker is really what I'm really aiming for.
And as you're writing it, are you thinking of a particular size of organization or aiming to make it broadly applicable, to tiny companies all the way up to massive, great conglomerates?
Yeah, well, as a consultant, I work with a fairly broad range of companies. So I think I'm aiming at more than one team. I would say if you're a company that's still a startup and less than 20 people, you might find the book interesting. But I think the real, it's like 20 to 2,000 developers is the range of people I talk to, and who are having actually, I think, similar problems because there really isn't that much literature or thinking out there of what happens when I have more than one team doing these things, or what happens when I'm not just doing greenfield, but I have a large legacy code base. Those kind of bigger problems are encountered generally by organizations that are, not one team building greenfield.
I really like the fact that, and as I said, it's
Yeah,
pre-release at the moment. So although not fully published, there are 4
yeah,
chapters
yeah,
available currently. I think more imminent. And I love the fact that you start with legacy modernization. It's
right.
very kind of counter the zeitgeist, where a lot of what I'm hearing about is greenfield development, and yet with my professional hat on,
Yeah,
talking to a lot of companies with, well, there's more code out there in the world that
yeah,
would benefit from AI input than is being generated on a daily basis. So um, it seems like a great place to
yeah.
start. Um,
I'm glad you feel that way because I was a bit nervous that it could be seen as somehow less cool. Oh, okay, dealing with code that already exists, that's a bit of a downer. In fact, I also considered calling the book Agentic Enterprise Architecture, and I was told that if I did that, then no one at all would buy it because even if they needed it, they would find it too
it's like
depressing.
that
But
Stephen Hawking quote about every
yeah,
formula you put in a book is going to halve your readership.
exactly. So if he hadn't put EMC, E equals MC squared in the brief history of time, imagine how many copies he would have sold. Yeah, so so partly I think it's just contrarian because, like you, I see a lot of people starting with a blank canvas, and I think that falsely gives people an idea about what can be achieved with agentic engineering. But also, it's because of that person, the frustrated person who's trying to apply their agentic methods at work. A lot of the what occurs to that person is, well, I have this 50 million lines of code, which is the upper end of what I've seen, but does exist. Um, how am I being left behind or whatever cliche? You know, how can this work for me? But actually the interesting thing is when I talk to practitioners, agentic engineering at scale seems to be more useful for legacy code where you have something to get the agent to sink its teeth into than actually other things. So I think as well as it being an underserved part of software, I think there's genuine reason to think that it's a quite a useful way to use coding agents.
There's lots that I could ask you about there. I
Yeah.
mean, where should someone start? Like, if they've got a big code base and they think that AI might be useful,
Yeah.
do you have any tips?
So I might start with the negative at first, which is don't just throw the coding agent at it. So I have actually seen a few people advocate this who I would bet have not tried it because they wouldn't recommend that if they had tried it. And also just even companies advising this. So, Anthropic, who make all sorts of interesting software that I enjoy using, had a post a while back on using Claude Code for mainframe modernization, and the message was effectively our thing is so smart that it can handle it, and that's not. I believe the experience of people who actually try this and succeeded in it. They don't just tell the coding agent to sick it. Normally, what people do is they end up finding that the code base as it exists is not a sufficiently structured or indexed way of looking at context. So almost everyone I've seen who is really tackling these things, in addition to uh, other disciplines like thinking about what is most valuable to split, etc., the kind of the business value thing, a lot of the first steps are about creating some kind of structured knowledge graph that preserves the parts of the code base that are relevant to their analysis and maybe drops some of the detail. So kind of a lossy representation is what I would see in common. So if you're trying to figure where can I make an incision to turn this enormous problem into a set of smaller problems that I can solve one by one. One of the most important things is just orienting yourself around it. And so if you can create some kind of graph, so I've seen people use, Neo4j or other ways of doing this thing where they digest the code base, then they can start asking themselves questions like, what are the capabilities that this thing actually does? Where are the seams that I might want to start pulling things apart? So we've, probably people who've been in software for a while have seen a lot of legacy decomposition activities. So we have a massive thing. Now we want microservices or smaller things. That process of figuring out where the joins are and where you can pull things apart, creating a knowledge graph of some kind, or tracking the data dependencies or some other way like that is really, I think, a really useful thing to do even before you start changing any code.
And presumably that's something that AI can assist with
Yeah.
under supervision.
Well, exactly. So you don't have to manually create the graph. The digestion process itself can be augmented with AI. I would say though that there are techniques for parsing code that have existed for a long time. So when my colleagues at ThoughtWorks have done this kind of thing with something they call code concise, creating a parser using the trad parser tools in order to create a dependency graph was part of how they did it. And so when they extend their techniques to a new programming language, part of what they do is create a new parser. It's also true that you could ask Claude, please help me write a parser for COBOL or JavaScript or C# that meets these criteria. But I don't think you should assume that all the work should be done in inference mode. I think switching between, I think Brigitte Berkler, a colleague of mine, talks about CPU versus GPU, whereas GPU is like the inference stuff with LLMs. You shouldn't necessarily do all the work on the GPU. So if you can create a parser that helps you digest that tens of millions of lines into a form that you can then enrich, for example, with an LLM adding context from the surrounding files, that's a good thing to do. So again, I wouldn't just get an LLM to chew through the whole code base as it is. I'd get an LLM to help me create deterministic tools that then help it to chew through the code base.
Mm. And you mention a variety of different kind of objectives, I suppose. A
Yeah,
sort of a modernization project can be triggered by all kinds of different needs. You might need
yeah.
to add, you might want to completely re-implement the code base in a new language. Can you say a little bit about how that might factor into decision making?
Yeah, well, I guess the fundamental problem of legacy code is normally we don't understand it well enough to change it. And that then manifests itself in being unable to serve a whole bunch of other things to your point. So it might be, I mean, very, very commonly, the problem is we have a new line of business. The people, our colleagues who are not involved in the code, um, think it should be a small project. We know it becomes a gigantic project, not because of the essential difficulty of what they're asking, but because of the accidental complexity of the code base that we've allowed to build up over time. And that's obviously a bit disappointing for them because what they're hearing is computer says no, and maybe they even think that we're being unnecessarily difficult, whereas we know that that's for a reason. So being unable to evolve it in the direction is one common thing. Another one is around things like stability. So a big problem can be these legacy code bases. If they're still around, it's probably because they're important for making a lot of money. They might be really hard to operate. They might have a whole bunch of bugs or fall over all the time. They might unnecessarily consume cloud resources because they're just one big thing that needs a huge machine and a huge amount of RAM. So those are kind of the traditional ones. But the third one that I heard from not just coders but information security people is terror that a massive legacy code base effectively means no security partitions within a whole bunch of important processes. So everything is in the one database. A compromise on one is a compromise on all is the sort of thing that doesn't make your infosec professionals comfortable, especially in a world where exploits are made much quicker due to bad people having coding agents too. So that one is, I think, something that can change the game a bit and actually justify doing something about the hulking legacy pile in the corner that maybe we didn't get around to tackling before.
And if you are in that latter camp with,
Yeah,
security fears, again, does that change how you might approach the problem? You talked about, analyzing how to split up a code base, boring
yeah,
deterministic checks and things like
yeah,
that. Yet we hear like get Fable or Mythos and just point it at a code base and it will discover a whole load of exploits, potentially zero
yeah.
days.
Well, I mean, I think patching is something that you can do quickly, and maybe that's a sort of an agentic loop. Oh, okay, well, I want to have, I don't know, a bunch of harnesses in place that tell me that I haven't broken the system so that I can get word code, codex, cursor, whatever else to fix things really quickly. I think that's a little bit of, man, the clue is in the word patching. That's kind of patching the problem rather than addressing the cause. I would say that without decomposing something really large and complicated into smaller pieces, you're not going to get solve the problem of evolution, the problem of stability, or the problem of security. You need those boundaries. I'm a firm believer that the lessons of modularity that we've learned over time are, if anything, more relevant now. And certainly, by the way, if you're trying to get coding agents to tackle large things, you will find that if you don't have any kind of modularity, this causes them to fill up their token windows very quickly by them being unable to work out what they need to understand in order to get their job done today. So it's not that different to a human being, with the exception that coding agents generally are, I I don't know about Fable, but as current models are generally not as good at as human beings at going up and down the architecture elevator as Gregor Hope talked about. So being able to think about the code base in terms of very large areas of different functionality, maybe medium level implementation or detail about how particular algorithms work. To a coding agent, all these details are just noise operating at the same volume, and it makes it quite hard for them to prioritize their attention. So I think, yeah, regardless of your goal, unless somehow coding agents or models become so powerful that they can just suck up an entire 50 million lines through a straw and not blow their context window, which I don't think is going to happen anytime soon, modularity and decomposition is still, I think, the foundation of getting things done with legacy code.
And this reminds me of what you were saying earlier about people problems, essentially, and
Yeah,
the organization is
yeah,
a big factor here, because I guess the way legacy systems often end up, Conway's law
yeah,
and the like, is based around team structures and internal dynamics. I guess
yeah.
to be successful, a project like this needs to be tackling those as well.
Exactly. And there's a massive amount of tacit knowledge usually in legacy systems, right? So I said, so partly you might say a legacy system is when um, our theory of the system hasn't kept up with the system. So, there's no human beings who have an accompanying human representation of the system. So now we're afraid to change it because we don't have a way of translating our needs into intention. Um, but I would also say that when you are decomposing a legacy system, looking at the a number of artifacts that aren't the code itself, whether it's like documentation or traces or I know, even core logs if it's a customer service system like I saw recently, and also the people who operate it. Those people's understanding of not just what it's doing, but why it's doing, their understanding of that these features are actually one feature that gets used together all the time. This other feature is something that isn't really used in the way it was intended. Those kind of human level um, understandings, the tacit knowledge, are quite important if you're going to not just do a code to code translation, but if you're going to
Hmm.
do a living system to living system translation. And probably I could say a bit more about that, but a lot of the elicitation techniques you need to work with those human beings is not what I've seen, which is either ask them to write down everything they know or write down everything based on what an LLM says and then just ask them to review it. I
Hmm.
think that uh, the way you get tacit knowledge out of people is not just to ask them, because that's not how people experience things. It's to, shadow them while they use the system or give them examples of key use cases and tell them what should happen in this case, uh, or observe them, or interview them, or basically these kind of interactive models allow them to surface the expectations they have about the system in a way that isn't just review this massive markdown file, and once you've given it a tick, I'll feed it to the coding agent and build more code.
Because reviewing is just this cognitively different mode of analysis, isn't it? Like,
Yeah,
but getting people in a room and starting to sort of
yeah,
creatively tease apart things just starts to get people thinking about things in a
yeah.
more
Where stuff like
creative
event sourcing
way.
is a popular activity, so you're engaging them in the mindset of conversationally interacting with the system. I think just like, yeah, I think reading and reviewing was never particularly good control either for pull requests or documentation or anything else, but it's becoming a much bigger problem when the bottleneck might even be of legacy modernization done naively, as I've seen it done, is just how much markdown a subject matter expert is willing to churn through,
Yeah.
because we're just generating so much of it. And I
Hmm.
don't, when I've seen it, I did not think, well, I didn't think it was effective, but I also didn't really think it was somehow respectful. It seemed to be a very low leverage way of getting these people to interact with the system. And it's not what you would do if you wanted them to hand over the system to a new human being was come on board. That would involve
Hmm.
metaphor and narrative and examples. So I'm really keen to use those kind of elicitation techniques that the user experience community knows very well to get that access to at least some of that tacit knowledge.
One of the things I appreciate about the book is the way that you link out to a whole bunch of other, sources and
Yeah,
references, and it really does feel like you're gathering together a whole bunch of some of it I'm sure is very new, but a lot of it is very battle tested,
Yeah,
good
yeah, yeah.
advice from a decade or more ago, and it feels like you're sort of holding all of these good ideas up against this new AI mediated paradigm and going, okay, what actually is still just as useful, if not even more useful, in this new world?
Yeah, I think so. So, there are old papers on modularity or on like programming as theory building is a very famous paper about that tacit knowledge that programmers build up at the same time as the code itself. I mean, even maybe the most classic example of kind of a nerdy way of looking at AI is Jevons paradox, which comes from a paper, maybe it's the 1860s, certainly a long time ago. So I do think that the fundamentals of how abstractions and information flows work have not been overturned by the presence of coding agent, but the importance or the accents on different things have. Plus, probably I just really enjoy reading through old stuff, and so that naturally, that inclination I have naturally causes me to gather together various sources from various times, like a magpie. So hopefully, if it works for you, hopefully it'll work for other readers.
There's a lot about it that makes me. I'm sure this is intentional, but there's bits that are quite amusing. And After Dinner Mints
Oh
is
yeah.
a title of one of your sections, which really made me laugh. I've never heard that before. I don't know if that's
Uh,
a Chris Fordism, but I think it feels relevant. Shall
Yeah,
we?
sure, sure. Maybe that's a good
Maybe it is.
example to show because I mean, it came up effectively just because I was drawing a really bad slide, and it occurred to me that that's what it looked like. So I think this is
So it's
original.
a
Uh, yeah,
neologism.
I,
Lovely.
I think so. So we'll see if it takes off. So for people who haven't read the early access yet, basically it's the idea of green fields within brown field. So one of the cases that I've seen people most successful at employing coding agents, not necessarily just to accelerate stuff they would have done anyway. Oh, help me get this test data into the right shape, and kind of a direct. They imagine the result after the coding agent produced the result. The coding agent produces what they had in mind, but actually transformative alternative approaches to getting stuff done is when you have a component that can be or needs to be replaced within a wider brownfields context. And so historically, dependencies are things that you should be terrified of because when your system plugs into another system, that means a whole other problem of interacting with another team or something more to understand or things that can go wrong. I'm not saying those things are totally overturned, but when it comes to coding agents, one of the really nice things is if you can give them outside in constraints and inside out latitude, in my experience, that maximizes their efficiency and effectiveness. So if you have an after dinner mint problem, where you can translate your problem into an after dinner mint, where you can create a new space that you can replace, maybe with specs or other ways of describing. It could be finite state machines or schemas or Allium, which I know you've worked on. If you can have things that describe the interaction between the green and the brown, and then you can get the agent to operate within a self-verifiable loop to create that new thing, it can be a quite efficient way of getting things done a lot faster than if you had to ask a poor programmer to retype code that satisfies all these outside-in wires that are sticking into the thing they're working on.
I can see it taking off. I'll
Okay.
do my
I think,
bit.
I, I think also just with these metaphors, it's just surprising enough to capture people's curiosity is always the
Yes.
case with I think with new ways of describing things.
Well, another surprising, excuse me, thing that I read is the way that you describe the existing system
Yeah,
as a kind of a spec.
yeah,
And I guess this, why don't we use this to segue into the world of spec-driven development? Why
yeah.
is a system a kind of a spec? I think a lot of people might not recognize that. And what does make for a good specification?
Cool. Well, I think this is a very hot topic. Maybe I'll start by just stating because I think there's a little bit of a either a fallacy or a convention I'd like to overturn here is that in the context of coding agent, spec should not just mean markdown. So I think
Yeah.
literally people think spec driven development is a way of making markdown driven development sound cool.
Mm.
And I don't think that scales, hence not being appropriate for a book that ends in its title with at scale. It's the sort of thing that can work for small problems where natural language is sufficient to capture the problem. But for any kind of larger problem, I think you need plural specs, you need specs that are multimodal, and you need to kind of add them up. So one of the many different kinds of, I think, effective specking might be to use a legacy code base as an oracle. And that's because it's literally telling you one version of the truth about what the new system should do. Now, that's not to say you can't overlay it with something else. So maybe you would also have you would have the legacy code base itself as a reference that you would give to the coding agent to look up. You might also have a finite state machine that reflects where you want the payment processing logic. You might even have something as fancy as TLA Plus, which is this modeling tool that's kind of popular in kind of hipster nerd circles. You might have various different representations of the truth, and it's my belief that the Swiss cheese model of quality applies here. So the Swiss cheese model of quality is I've got and use it in aviation a lot. I have multiple layers, and they have holes in each layer of safety. But so long as those holes don't line up, then something that goes through a hole at one layer will get caught at another layer. So when it comes to specs, I think this combination of different ways of looking at the truth are both important for resilience so that you don't have just something that isn't covered by one way of speccing the system. But also it allows the human beings who are working on it to have different affordances for how they might want to describe what they want. So, different kinds of specification might allow them to communicate different lenses that they have on what the system needs to do. And since coding agents actually, I think, work quite well when you give them multiple different sets of constraints at once and ask them to combine it, that's what I would recommend for spec-driven development, not just a directory of Markdown.
Mm-hmm. And I guess that suggests that you might end up with challenges where different specs are not just adding a different facet on a problem, but maybe slightly contradictory, or there may be friction between these different representations. How much of a problem is that in practice?
Well, I think it's been a problem with modernizing legacy code before we had coding agents, and it's still a problem when we do have coding agents. But maybe it's one that we can resolve a little bit more easily. So if we think about, I guess back in time, you might have the documentation about a system, you might have the system itself, you might have, I don't know, its runtime behavior that might involve weird things being deployed in production that actually somehow change with configuration value or dynamic loading of logic might change things. So you always have the problem of there being multiple truths of a system. The way that I mostly recommend tackling this is with what I might call decision specs. So basically, at the point where you are combining the specs together in some kind of, I don't really have a good word for it. I've heard people use super spec, but that feels a bit monolithic. But this spec collection that helps you decide what the system should be doing, this kind of reference harness, is that where there are ambiguities, you, rather than just leaving that ambiguity to be resolved dynamically through the generation process, you create a decision record for how you would resolve that. So if it turns out, the coding agent pushes back on you and says, well, you said the payment flow should work like this, but I can see that there's a code path where in fact the refund doesn't work like that, and the refund could take an unbounded number of days rather than happen within 14 days. So which do you want? I can't do both at once, but please, resolve it for me. Well, then you could write effectively an ADR or a product decision, communicate that in some way. Could include Markdown, might not have to be Markdown, and then that becomes part of the composite experience. So that if you want to repeat the process of generating code again, you don't ask the coding agent to pick another random decision amongst the ways it could resolve it, but you actually get the merge conflict, so to speak, materialized on disk. And I think that ends up being actually a good way of helping you interrogate the problem, because anytime there is a contradiction between layers, it's usually something interesting, I would suggest.
So it sounds like you're seeing specs as something which are realized incrementally, and perhaps by asking
Yeah,
the coding agent questions like, am I being unclear? Where are the ambiguities? I guess
yeah.
they might not offer that up proactively. And that they're durable. It sounds
Yeah.
like these specs which have a long life. Am I following?
Well, I think the durability is an interesting question, because I think there are more than one way of approaching this that hasn't quite shaken out yet. So I think my preferred method is certainly that you have specs that are durable over time. I might suggest the traditional way of doing software development de facto was to have temporary specs, because you would write stuff down when you're first creating the software and then you wouldn't maintain them over time, maybe with occasional exceptions. So I think the way, maybe this is because I'm a consultant, I think of this as there being kind of four options: whether the code itself is something that you look after and pay attention to over time. There are some maybe people who are really keen on pushing coding agent work as far as it goes, that are treating the code not itself as durable, be it temporary. And then you also have the decision about whether the spec is durable or temporary. So you might say that vibe coding corresponds to a situation where you are not caring about having long-term custody about either a spec or the code. You are kind of pinging things at the code and it evolves as you want. And so it's not really anchored in anything. And so it can evolve in any direction really quickly. That's great. It also could degenerate or kind of go off course really easily because you're not taking responsibility for either side of the artifact. Whereas in the spec anchored world, to use Brigitte Werkler's term, both the spec and the code are things that you care about and look after over time. You can, of course, go to the extreme, which is you care about the spec and you don't look after the code itself, which is, I guess, spec as code kind of arrangement. So basically, you have various options. I would suggest that one decision that teams need to make is to be sure that everyone's on the same page as to which thing they are taking responsibility for custodianship over time. Because if it's not clear, then you do end up in kind of inconsistencies, and someone changed the production code and they didn't update the spec, for example. That is always a slightly annoying thing if you're coming onto a project and you find the docs and the reality don't match. I would suggest it's particularly dangerous, not just annoying, when you have a coding agent who can't really access the tacit knowledge or context to know why things are inconsistent and maybe suffers from unpredictable behavior because of that.
So there must be some emerging workflows around having teams collaborating on not just the code, but also specification and kind of trying to mitigate that risk that the two drift out of sync. Have you seen any sort of particularly good ways that that's being done?
So I guess the two ways I see the kind of the hipster way is what you might call Phoenix architecture, which is damn the code, full steam ahead, kind of. And so the workflow is any change you make is via a change to the spec, whether it's what you might call a constitution spec, which is this is my design that I need to keep integrity of over time, or feature spec, which is this is how this particular thing works. So there are people who I think maybe talk about this a little bit more than actually do it, because it's definitely on the progressive and tricky end. But like the workflow is you change the spec and you press the generation button again. And because you've got such a good set of harnesses for both quality and preserving the intent that you have, that's fine. You don't need to look after the code. All your intent and quality assurance is held within the spec territory. What I see more often, though, is still in XP style stories that are thinly sliced that cut through both of them at the same time. So, teams that will submit a pull request or even make a change, depending if they're using a pull request oriented workflow, that will cut across both things. Analogously to updating maybe tests and production code. So, I have seen in the past workflows where there was a different team maintaining the tests than maintaining the production code. So the production code would get ahead, the build would be read in weird ways, and then it would be the job at the end of the 2-week sprint for the team to frantically reconcile the two to hopefully get one green build that they could push live. To be clear, I haven't seen this in a long time and not since I joined ThoughtWorks, but that eventual consistency model I think is not very useful. I think that kind of, we have a user story that represents a change we want to make to the system, so we'll update both the spec and the code and tests at the same time and in sync in a small way is what I would recommend.
And thinking about the so like you hear about the Phoenix architecture.
Yeah.
I can't say I've seen anybody actually fully committing to that way of working yet. But presumably, well, and it's linked to the point you made about I think it was nerds and TLA plus.
Yeah.
Certain kind of formal specification languages are having a moment right now. It's changing the economics of whether it's worth investing time in these things.
Yes.
Um, yeah, are you seeing that yourself? That are there new languages coming onto the scene that people haven't really been paying attention to for a while?
So I think I haven't seen any new languages that are coding agent optimized. I've seen the argument that I will attempt to refute in a second, that coding agents mean the death of language innovation, because unless your coding agent is trained on an enormous quantity of code out there, it won't be very good at the thing. So sorry, JavaScript and Python it is. Your new language might be cool, but it's never going to get enough of an install base to be usable by a coding agent. My reason for attempting to refute it with some speculation is I think that the ability to pass context, maybe you could say feed forward context in this case, a language guide for a new language to a coding agent, is something that really the fundamentals of this paradigm do make quite easily. So I do think that if you needed to create a new DSL, even for your particular project, or if a new programming language were to emerge that would be more agent friendly, I think it doesn't have to be communicated how to use this through the pre-training. It could actually be provided through context enough to work well with at least the latest generation of coding agents. So I think that would be possible. However, more what I'm seeing now is the effect of not needing to learn how to use these tools that maybe you saw someone use at a conference once and you want to try out. That's actually something that is taking off. So mutation testing seems to be having a renaissance to me. Okay, so we want to get ourselves confidence that our tests have good enough coverage, so we'll mutate the production code in lots of different ways and check that it causes a test to fail. That's something that a lot of people knew about, and that a lot of people didn't really know how to set up in their programming stack of choice. However, if you're using a coding agent, then you can suggest that it does that, and it can be an experiment, and you can add that new kind of like alternative way of doing QA that isn't just writing unit tests and journey tests really easily. Same with property-based testing or formal modeling, as you suggest, or really even production A/B tests that feed back into the development process by giving the agent feedback about how users are actually using the software. All these kind of alternative ways of quality assuring code, I think, are having a moment, because you don't have that thing where you're like, well, I know it could improve the project, but it's going to take me at least 2 days to figure this out. I don't really have time this sprint, this whatever. And if it doesn't work out, then my teammates are going to be annoyed at me because I, quote, wasted time, unquote, on trying something out. So you're kind of exposed, and it's only the really passionate people who would make it past that barrier. But that barrier has dropped quite a bit, because you can delegate that to a coding agent who probably does know about these techniques or could learn about them quite quickly. So not really new languages, but new techniques, or old techniques applied in a more popularized way. That's what I see.
And I guess it's not just the the scouts who are off testing what new approaches might be
Yeah.
possible, but I guess perhaps it's easier for a team to adopt as well if they don't actually have to learn, for example, the arcane syntax of TLA
Yeah.
plus.
Well, a lot of teams these days are, they might have their own list of skills, or even I would say some organizations are starting to create organizational harnesses where they're sharing things. But even if it's just a team, someone wants to add a new bunch of property tests in order to really stress test the refund logic is the thing in my brain, because that's kind of the way that my retail clients can probably figure out how to lose a lot of money if they get that wrong. So you create a skill that helps the rest of your team to create new property tests in the future. That doesn't mean that you don't have to accompany that with human communication alignment, the kind of socialized tacit knowledge transfer of explaining to them why they should care about it, get them excited, or what the significance is. But the syntax itself becomes something that you can write down a guide for, and that can get sucked up into the coding agent as your teammates use it, and off they go.
Is now a good time to ask about that diagram behind
Oh
you?
yeah, yeah. Subtle propaganda.
Yeah,
Yeah.
yeah, yes, because you mentioned the
Yeah,
feedback feed forward. I can
yeah.
see sensors and checks, I think.
Exactly. So I think there's so in harness engineering in general, I think there's two distinctions that are really useful in working out what kind of harness you're talking about. And so I will claim that the two distinctions that really help to sort things into a taxonomy that might be illuminating is feed forward versus feedback. So a feedback harness is one that is actually pointed at the code that you generated and gives you information back into the coding agent or the generation process. So I guess a test might be an interesting example of that. A feed forward harness is one that gives context to the agent to make a good decision the first time round. So one of the things that I claim in the book is you need a balance of these. That if you operate just on feedback, that's like trying to iterate your way to a solution by kind of banging your head against a wall, or just randomly crashing around, tripping over furniture and trying to get to a good place. It's something where you're not going to be able to, with small signals, hone in. On the other hand, if you only operate with feed forward, which is guidance about what you should do, you're not going to have that fine-grained feedback control to really nail it. So that explore, exploit in evolutionary terms, how do I find the right subspace in the solution space that I'm generating from, and then the feedback to actually assure myself that I've nailed it. I would say that's important. And I see teams over indexing on either feed forward or feedback. They try to iterate from nothing with not enough guidance. They don't communicate the intent. They just communicate the kind of how close were you to the agent. I also see teams communicating just good intentions through feed forward without the feedback that allows the agent to really mark its own homework. So that feed forward versus feedback, which is a distinction that comes from control theory, is one distinction that I think is quite important. The other distinction is about whether the harness you're giving to the agent is normative or informative. So if I can explain that, like a normative harness is one that tells you correct or incorrect, or it tells the agent correct or incorrect. So the example I gave earlier of a test, that's both feedback because it's pointed at your solution, and it's normative because either it says good solution, great, go ahead, or it tells you no, this is wrong. Now those two distinctions together give you four kinds of harness. So the tests, or as I would call them, checks, to be a little bit more generic, are really useful ones that are both their feedback and they're normative. So they're really useful for the agents in a loop because the agent can use that to mark its own homework, to enter a loop and to iterate, to have I got it right yet? No, and to keep going. You can, however, have feedback that is not normative, that is informative. So maybe the classic example of that is if you have you give the agent eyes or ears or whatever sensory organ, for example, Playwright, so that the agent can perceive the web interface that it's creating. That doesn't tell the agent yes or no, correct or incorrect. It lets the agent perceive what's going on and then leaves it up to the agent to know how to use that information. So kind of the agent has to supply the judgment. So that's kind of a useful distinction. And I think it's also in feed forward, so input into the generation process. You can have some things that are pure guides, as I would say in my taxonomy, which is, I don't know, Cloud9 documentation on how a particular library works, or to go back to our earlier comment about legacy code, it might actually be a map of the legacy code base or a map of the current architecture so the agent can apply its own judgment. But it could be normative, like it could be a list of ADRs, or it could be a schema that actually is guiding the agent and telling the agent yes or no in a way that makes sure your intention is preserved. So my thesis is really these four things are all important, and if you over-index on any subset of harness, you're likely to not get as good a results or as faithful a results to your intention as you otherwise would.
It's a really useful mental model, and it it makes me wonder how does this connect to kind of decision making? Because again, I read in your book it's that famous distinction between one-way and two-way
Oh
doors.
yeah.
So you mentioned, the last responsible moment, where ideally you want to capture as much information before making a decision as you can, but not any later, because then the decision won't get made for you. How does that feed into coding agents in general? It seems like there's this balance between what the agents are up to and what you want. You don't necessarily want to be too prescriptive, How do you find that balance?
Yeah, so I think it's an interesting question about the kind of normative informative split, because you might say that the smarter agents get, the more you can just give them a hint. So maybe if you're using either an older model, or somehow you don't understand the space, you need to be more prescriptive, just like you would if you were delegating to someone. And so you have to say, no, it has to pass these 500 tests, for example. If you're using a really intelligent model, you might be able to say, well, here's a informative harness that lets you know what's going on, and I can trust. I was about to say intelligence, which isn't really the right word, but I can trust the implied computation in the LLM enough that you can make a decision on your own. You can supply the judgment. So I think that's sort of one aspect of the split. But in terms of the one-way door versus two-way door, it can also be that if it's cheap to build something, it can turn things that were a one-way door because of the excessive investment that you couldn't really easily recurve into something you can try out. So maybe if you have two ways of doing something, you could debate to death what it is that would hypothetically be the best way to solve it, or you could define the limits of the problem, pass it to coding agent as a harness, and then do both, or do all three, or even literally deploy both versions in production to see. So that the fact that investment of engineering effort is something that need not be such a heavy thing means that you can make some decisions more lightly. There is, just to your point about the way I blend in threads of all sorts of different sources over time. There is, in fact, in Japanese manufacturing, the concept of set-based engineering, which the idea is of preserving optionality. So if you structure your production line of cars in such a way that you can keep your options open and preserve multiple options, then you only need to collapse that option at a later date. So I would say, to your point about decision making, this is a way that we can take inspiration from that with coding agents, because if we structure our workflow around coding agents, we can afford to keep more than one option in play longer without having to converge or settle on one way of doing it.
Mm. And it seems like there's a is this a kind of complementary or mirror at the team level as well? Because a point that really struck me was when you were saying, if you've got intent
Yeah,
documented well enough that agents can be working on
yeah.
code, then the teams don't need to be quite so linked to the code that they're working on, and
Yeah.
perhaps you could have slightly more floating, loosely coupled relationships between teams and code bases.
So
Did I follow
certain,
you
yeah. So
correctly?
you have, and this is one that I was even hesitating to bring up, because I think it's an idea that I believe in, but I also am very sure that it will be misused. So it's okay. So as long as you, me, and your listeners are responsible, Henry, I think this will be fine. But um, it is my experience that it is easier to scale teams down, maybe not necessarily to zero, but certainly to lower, because the oral tradition of passing on knowledge simply by socializing, like person to person. Oh, okay, this Lambda function was written before your time. Watch it; it's a feisty one. Or the reason the database works that way, it seems a bit silly to you now, but you have to understand that it has this history. Or even, this design of the code uh, is for a very good reason. And if you change that design, you will regret it, just like the last two people who tried. There's a lot of things that you would pass on that are very much person to person conversational. If you've got enough intent, whether it's through this multitude of different kinds of specs, or you've got the ability to introspect on legacy code, or you've done the work I suggested earlier of, kind of ethnographic research of finding out people who've maintained the legacy system, what's going on, and you're able to capture that in explicit form, then you might not need, as a developer, to be walked through each individual part of the code base, and you might be able to, when something goes wrong, quickly, if I could use the metaphor, hydrate enough understanding to work on it, so long as you understand the overall intention. There's a couple of reasons why I think this is kind of scary, though. One is the interplay between tacit knowledge and explicit knowledge. So Polanyi famously said, "We know more than we can say." So you might think you've got everything written down, but you don't. and that will look fine until there's some kind of incident or something that unexpectedly stresses the system. So that would be a way that this raising of the altitude of people maintaining systems could actually bite you in the long run. The other problem is that this is just really, really tempting for a manager to exploit. So, some of my best friends are CTOs. So no shade, sorry. But one of the massive frustrations when you're a CTO of a larger company, so more on the 2,000 developer size company that I mentioned earlier, is that you think you have a lot of energy and human time to direct towards really important initiatives, but you find that almost all of it is allocated by the need to manage cognitive load of this oral tradition of talking about systems. So you're like, oh, this is great. The CEO says we've got these three things that are going to save our business, get us ready for the disruption of AI or whatever else. Okay, great. Well, I've got 2,000 people. No worries. Let's get them on it. And then what you find is you have very little liquidity. What you find is that you're like, oh, okay, well, I have to have that team here because they're maintaining that system, and I need to make sure I'm not really changing it much, but I need to make sure there's enough people onboarded with it that if I need to change it in the future, I can do so. Oh, okay, there's other 100 people who work in this area, and so you find that the amount of discretionary focus you have in your organization is shockingly low, and that's kind of frustrating because you went from thinking I have a big problem and a big bunch of people who can help me with it to finding that I don't really have that, and I'm almost constrained with these initiatives to only make use of the time of the human beings who are already working on the systems implicated by the initiative. So there's no kind of swarming on a problem. So if such a CTO were to wishfully think that they'd achieved a case of externalizing enough knowledge that they could do this, they might start by saying, okay, stop maintaining those old systems. They just take care of themselves, right? Everyone rush to this side of the boat. It's really important that we look at this new thing. And for a while, it could work. And then what you could find is that there's an atrophying of knowledge that was actually important because you didn't manage to get the balance right. You've underinvested in human beings' ownership, and then that you only realize that you've gone too far after it's too late. You have to switch back to something else, and you found that you've kind of legacified a lot of your estate by our earlier definition of, you've lost the tacit knowledge that manages it, and you've only got the code artifact left. So that's why I'm nervous about talking about it, because I think the ability to swarm on the most important problems will be something that companies that can use coding agents really well will take advantage of and succeed with, and they'll be like, well, they're operating with, 80% of their effort working on the most important things as opposed to 20%. But there will be companies who have not put in the work, have not externalized the knowledge, don't have that control, who will try it anyway because they'll want it to be possible, and they'll find out a bit late.
Yeah, it's fascinating. I mean, you mentioned Peter Nauer programming
Yeah,
as theory building
yeah,
earlier, and it's a sort of anathema idea, isn't it? For him, the job of programmers was to build that mental model of the system, and the code
yeah.
was a kind of almost a side effect. And we're talking about something which is, completely inverting that.
Yeah, so I think coding agents definitely, like, they change the equation. So it does make it, if I'm entering a code base I haven't worked on for a while now, I will normally ask for a tour or have a dialogue with a coding agent, and it will become possible for me to make meaningful change much quicker than my old kind of poke around and just do some greps and stuff method. Or it's probably also quicker even than the other method, which is let me find a time in the calendar of the person who used to work on this if they haven't left the company and let them explain it to me. So definitely, like, the transition between tacit knowledge externalized through the agent and then internalized to me again, that's definitely accelerated. But I don't think there are some fundamental limits about that. And I think there are maybe some rationalist fallacies where people want to ignore Peter Noah's lesson and just think, okay, my company is just the code. So, it's just everything I've checked into GitHub. That is the entirety of what needs to be known in order to get work done. It would be really convenient if that were true. It would allow me to, you know, uh, maybe denigrate the contribution of the humans in the system and lean into the AI hype. So I'm gonna pretend that Noah didn't know what he was talking about and say that programming is code production only. And I think if you do that, it's one of those things that might work for a while, but eventually reality will catch up with you.
You don't see your code rotting until it's too late.
So
You take a
it's
peek and yeah.
exactly. So you might say that accumulation of tech debt is a one-way door, but it's the most worst kind of one-way door where you only realize you've gone through it when you kind of look back and say, oh, that was a door I walked through.
Mm. There is this relationship, though, isn't there? Like we can't avoid it between what we were talking about with legacy code modernization as well.
Yeah.
And if we're saying AI can actually help with that enormously, then the legacification of your estate, changes the economics in both directions.
Yeah, exactly. And that's one of the other kind of payoffs of starting my book on legacy code is that, one of the things that I'll talk about later is the techniques you used for understanding or keeping track or harnessing of these large legacy systems are also techniques that continue to be relevant when you're generating new systems. So they're kind of, there is a later section of the book called Regenerative Engineering, where I'm kind of exploring that system of avoiding the boom and bust of tech debt, but still just because you don't have any legacy code, hopefully, if I convince my reader, won't mean that the techniques you needed to use to understand legacy code are irrelevant. They'll become part of kind of ongoing feedback and sensing mechanisms that you use to keep your systems fresh and green over time.
So I wonder if this is pure speculation, but in the way that we're seeing that in sort of in diligent hands, it's possible to invest the time in building more rigorous
Yeah,
software than was easily possible previously. You could do it, but as you said, it would take a bunch of investment. Perhaps that in making sure that our coding agents know how to navigate the code base effectively,
yeah,
that kind of the legacy half-life or something, the decay changes somewhat because you've had to invest all of that time in good context. That it's not necessarily sure the business might move on. I don't know, regulation changes or whatever. There'll be
yeah.
environmental factors, but perhaps AI might be a force for keeping code fresher for longer.
Well, I think quality is optional as part of the problem. So it's not
Mm.
just you get the coding agent, look at it, and it's better. So I do believe that the ceiling of what quality is possible is improved now, especially with respect to the accessibility of the variety of alternative QA techniques we have. But it's also possible to do a rush job. And I have a slight
Mm.
pessimistic take on this, which is
Right.
I think that we as an industry, without a culture change, at least, will not tolerate improvement in quality. That as soon as if we did sustainably experience improved quality, we would compensate by doing more of a rush job or engaging less because the limit of quality of our software was never about the maximum quality we could achieve, but basically like the minimum quality we would accept. So if we apply the same kind of rush and rigor slash lack of rigor, then I think we'll fall victim to the quality version of I think I'm going to pronounce his name wrong, but Worth's law, right? So computers get faster, but computing doesn't get faster,
Mm.
right? So why is that? Well, that's because the
Mm.
faster the hardware gets, the more we waste, and the limit is basically the point at which our users will refuse to engage with our software, not how fast we could or snappy we could make it. So I think with quality, without a culture change or without users demanding high quality, without that kind of self-imposed desire for us to do a better job than we used to, the natural tendency will be to drift to the same amount of defects or instability as we previously had because we'll fritter away the leverage that a new set of techniques, in this case, coding agents, will give us. So sorry if that's
Mm.
a pessimistic thing, but I think I'm trying to make it
Well,
a
I
culture
can't let
call.
that be our
Yeah,
the
yeah.
last question. So,
Oh, exactly.
uh,
Yeah,
who knows? Maybe this one's not going to be any better. But we both work for consultancies,
yeah,
and now, of course, anyone with coding agents may be able to build a
yeah,
good enough version of a whole variety of different kinds of systems.
yeah.
Just wondering about your thoughts, really. Is there still a place for us? Hopefully, but if so, what's that edge?
That's interesting, as I was trying to work out as you were asking a question whether the audience would regard the death of consulting as the good outcome or the bad outcome. I couldn't really decide. I know for us it's a good outcome. So I think what I would say is that um, uh, l- low leverage consulting, where you're handing off code production only to a bunch of people that you don't trust or engage with, is the most disruptable, because that's quite similar to what you would do with a coding agent. I think that high leverage consultancy, where the consultant brings more of that tacit knowledge, more of that knowledge about how different approaches have worked over time. Maybe they facilitate out of you some of your what you actually want to have happen. Those kind of guidance and judgments based parts of consulting, I think, will become more in demand, because with coding agents, that help that consultants can give their clients has higher leverage than before. But yeah, I think if it's the equivalent of, and I don't say outsourcing specifically about geography, but if it's just I have a I know exactly what it is that I want to build. I have the equivalent of harnesses, because I have like really fine grained requirements and test cases, and I will just pass that over to someone who has either has a lower wage than my employees, or who I can disengage when I don't need them anymore more easily than my employees. I think that kind of consulting will take a hit, and that's not zero human consequence, because that is a modality that there are a lot of smart people hired in. But I think the onus is on us as consultants to try to move into the judgment advice space, as you think the word consultant should mean. And if we do that, then we'll find our services more in demand, not less.
Well, on that note, I think, Chris, thank you ever so much. For anyone who wants to read your book or find out more about it, what should they do?
Well, they could probably, if they Google O'Reilly Agentic Engineering at Scale, they'll probably they'll find it. I hope perhaps that there could even be a link attached to this episode of your
I'll find a
excellent
link in the show
podcast as well.
notes.
But that will be the early access, so that'll be available to O'Reilly subscribers. And there's 4 chapters out now, and that more will be coming shortly, as you kindly hinted before. And so, they should be able to find out more there. Probably a lot of my hot takes in unprocessed form happen on LinkedIn as well. So if you're after the kind of the incendiary thought before it becomes the reason chapter, then if you follow me on LinkedIn, CT Forward, you may get a preview of things even before they end up in a draft.
That's good advice. I'm really enjoying following you at the moment.
Sure.
Thank you very much, Chris. I really look forward to reading the outstanding chapters when they're available.
Sounds great. Thanks very much, mate.
Thank you.